Hi, my name is Jinxi. I'm a graduate student. So first thing here, I'm gonna talk about all the search algorithms because I want to make sure to go through all of them. So first, let's look at BFS. In BFS, I have array deck. I'm using array deck to pop off nodes and add nodes. So in the case of BFS, I'm adding nodes to the end of the array deck. So here, to avoid duplicates, I'm using a hash set. It's right here, and right after the hash set, I'm entering a while loop. And in the while loop, the first thing I'm gonna do is to pop off the first node, and after that, if the node is not the goal we want, we add it to the hash set to avoid duplicates. Then we get all the children nodes, which is by calling the successor function, and we put all those nodes, children nodes, into a list, and a for loop for the children list. And then each children, we add it to the end of the array deck. And then that's it for the BFS. So next, I'm going to talk about DFS. So it's kind of similar, but the difference is, instead of add nodes to last, we add nodes to the first of the array deck. Then the rest of the codes are kind of similar, but right here in while loop, the same thing is we get into the while loop, we pop off the nodes and check if the node is the goal we want. If not, we add it to the hash set, and similarly the successor function. So next, let's look at iterative deepening. So the difference is, in iterative deepening, we have a limit. So I'm setting a limit to 2 because my first level is 1. So here, we have a while loop, same as a depth first search, but right after I'm popping off the nodes, I'm checking if the depth is over the limit. If it is over the limit, we break the loop and continue with the outer while loop. So let's look at uniform cost. So in uniform cost, because I wanted to pop off the smallest cost every time, so I'm using a tree map. It gives a sorted map. So every time I pop off the first one, it is smallest cost. And same thing here, I have a array deck. So, and also I have a hash set. The children list, we add it to the tree map first to make sure it has the right order. The smallest always at the front. Then let's look at the best first search and A star search, and they are basically very similar to uniform cost. The difference is the best first search use heuristics, and in this case, heuristics is the how many different how many numbers are dispositioned, and so rest of them are very similar. So A star search use both heuristics and the local cost. So add them together, and we determine the smallest. Then add them to the end of the queue. And for star 2, A star 2, very similar. The difference is the estimate function is Manhattan distance, and add that to the local cost, then determine the smallest, then put it on the queue at the end of the queue. And the last one is A star 3. So in A star 3, the estimate function that I choose to use is in a one-dimension array to compare the goal state and the current state, and calculate how many steps I need to put a number into the right position, and add all those numbers together to get a Manhattan value. And that's and add those Manhattan value to local cost, and determine the smallest, and put the end of the queue. So last, I want to talk about the three classes I use for modeling the problem. So the first is problem state. So in problem state, the successor function is valid moves. So valid moves determines the next state, and also how much does it cost to move to the next state. And another class is called search tree node. So in search tree node, it's a wrapper class for it wraps around the problem state, and its successor function is set children, and wrap around the problem state. So each node knows how deep it is, and from a node we can get the problem state in the node. So in turn we can know if we want to move to next node, and we know how much does that cost. And the last class is game board. In game board, basically just includes goal state in one array version and 2D version. And last, I'm gonna show my code works. So here in the terminal, I can choose, for example, BFS. I can choose hard mode. Then here's the output. And let's try another one. A star 3. Let's try a medium one. Then the output is right here. Let's try the last one. Let's try greedy search, and do hard mode. Then we have the result right here.